All right. So today we'll be talking on section 4.4, and also we'll try to save some time so that if you have any question on the test, especially on chapter 1, we can go back and look at some concepts from there if you have any. So again, we are covering trigonometric functions in chapter 4. So in this chapter we'll explore, we still have those 6 trigonometric functions, but right now we'll be talking about any angle in the trigonometric functions. For an example,
if you look at these images here, we have 4 graphs at the bottom, and as you know that we have 4 quadrants because of x and y's. So far we assume that the theta is an angle which is less than 90 degrees, which is an acute angle. But now we don't have that restrictions because you can have theta in any quadrant. Okay? And we'll be assuming something like this. If you look at the first image, which is A, if you look at this, we'll assuming that our x and y's are the, for an example, if theta is created at the center, the x is your adjacent and y is your opposite, right? And based on x and y, you can find the r using the Pythagorean theorem, right? So r should be the square root of x square plus y square, just like how we, because you know Pythagorean theorem is true for any right angle. So if this is your x and this is your y and this is your r, so you can always find the r using this formula, square root of x square plus y square, again coming from the Pythagorean theorem, because Pythagorean theorem applies only to the right triangle, which says that the square of hypotenuse equal to the square of opposite side plus the square of adjacent side. So now, so you see that all the 6 trigonometric functions are still same, but we just replace those opposite, adjacent, and hypotenuse by x, y, and r. For an example, in our case here, anytime you have adjacent, that will be x. Anytime you have opposite, that will be y. Anytime you have hypotenuse, that will be r. So we just replaced hypotenuse, opposite side, and adjacent side by x, y, and r. And we just modified those 6 functions. So still we have the same functions. Remember in the last chapter, last section, we talked about the trigonometric functions. We know their original ratios, and then we also looked at trigonometric functions based on the unit circle where r was 1. Now you don't have 1 as an r, so r can be anything, any real number. So that's why we have r here. So, and these are the formulas modified. Remember, this is the same formula, just modified. Now, we are just trying to show you that all the angles, I know that we all know it, but just to make sure, the first, if you look at the first circle, we are just showing you that all the angles in the positive direction, right? So you start from here, and 30, 45, 60, 90, you go all the way to the end. And in the other, in the second triangle, I'm sorry, the circle, we are showing you the angle in the, if you just go to clockwise, because if you go clockwise, you will still have the same angles but negative direction. So you know here, so for an example, the angle 30-degree angle is in the negative side. That is basically negative 3 30-degree angles. So you know these two circles are used just to see how things get changed when you are moving positive or the negative direction. And this chapter will give you a lot of concepts and direction about how to capture the negative angles, or how to measure the trigonometric functions for negative angles. Now here, I think we have already known it, just to make sure we know it again. So sine is basically 0 at 0 degree. 90 degrees sine becomes 1, 180 again 0, and 270 becomes again negative 1. You know, all the sine values are changing from 1 to negative 1. And similar is true for cosine as well, the cos theta. You see this At first that's 1, 90, 0, and then again at 180 it's negative 1 and 0. So it's basically fluctuating between 1 and negative 1, both sine and cosine. Okay. But the tangent is a little bit different because you see the tangent has zeros and undefined. It's undefined because of this. Because remember, the tangent has a formula. What was that? It's a sine by cosine, right? So what happens at 90, that sine is 1, cosine is 0. So you are basically dividing 1 by 0, which becomes undefined. So which is again true when, and as you know that all the trigonometric functions, all the 6 functions are basically periodic functions. They will be repeating the same values again and again. So that's why you see the repetition. Look at the tangent, 0 undefined, 0 undefined. So it will be always going 0 undefined after each interval of 90 degrees. For an example, this is 270. So it becomes 0 again at 360. Okay? It will be again undefined at 450. So after, you see what I'm saying? So because what happens if you keep going, I'm saying, let's say whether you are moving clockwise or anti-clockwise,
if you keep moving, even after 360 degree is completed, even if you, after that, if you keep moving, all the values will be repeated. That's it. There will be no change, technically. Even if you go back here, interestingly, if you look at carefully in these two circles, look at this, 30 degree and negative 330 degree. They are basically same. Look at this. Their lines are same, right? That's why if you try to take sine 30 or sine 330, you'll get the same value. You see what I'm saying? Because technically they are in the same line. Even if you try in the calculator sine 30, you'll get half, right? Sine 30 is half. If you try sine negative 330, it will be still half. Because the values are repeating. And also if you look at here, 330 and 30 is basically the same line. Just the only difference is you get 30 when you go to the positive direction. You get 330 when you go anti-clockwise, the clockwise, and you come back all the way to the first quadrant, right? So that's why it's technically they are the same values repeated. So for an example, let's say 150, sine 150, and sine negative 210. You'll again get the same value because they are exactly same line. The only difference is clockwise or anti-clockwise. So similar is true for all the 6 trigonometric functions. Okay. Now let's go to a little bit more here. Okay. Now evaluate the cosine function and cotangent. I think we already did the cosine. Cotangent function at the following 4 quadrantal angles. So following 4 angles. So we did it for 4 angles for sine, cosine, and tangent. Can you do it for the cotangent, which is cot? Like, can you do that? So what happens for the cot? Remember, the cot is what? Cosine by sine, right? If you remember there are some identities, right? So cot theta is cos theta over sine theta. Now based on this, what will be here? Undefined, right? Because cos theta is 1 and this is 0. You are dividing 1 by 0, undefined. What will be there here? 0, undefined 0. It's basically repeated. Undefined 0, undefined 0. After period of every 90. At an interval of every 90, it will be repeated, same values. So what it tells you, that the values are repeated between 0 to undefined. So there are plenty of basically numbers the cot and sine, tan can have. Now, more interesting part, as I said, that how the signs of different trigonometric functions are defined. So this you see we have x and y axis here, okay, and as we now know that we don't have that restriction that the theta has to be acute angle. Theta has to be less than 90. It can be more than 90. It can be anywhere in this 4 quadrant. It can be here, it can be here, so it can be here, and you can either count it as a clockwise, anti-clockwise, because we know that it doesn't matter how you count, the clockwise or anti-clockwise
at the end the value will be same. Now, if you look at this 4 quadrant, interesting is if your theta fall in quadrant first quadrant. Now, when it falls into the first quadrant, if it is 0 to 90 for sure, right? 0 degree to 90 degree, all of these falls into first quadrant. Or if it is more than 360 and less than 450, still it falls into first quadrant, because what happens if it is less than 390? What happens? You start from here, okay, and then you go all the way up to here. So you complete 360. You have to go another 30 to make it 390. So you will go next 30 here. So still you are in the first quadrant, right? So as long as you are at the first quadrant, all the trigonometric functions will have positive values. I'm saying 1, 0.5, 1.73, whatever it is, that will be positive. Okay. In the second quadrant, only the sine and cosec, because sine and cosec has a relation. Remember, they are reciprocal to each other. That's why whenever sine is positive, automatically cosec is positive. I'm just trying to show you the relation, that why they said sine and cosec is positive. Sine and cosec, they are positive because they both are inverse to, I'm saying, the reciprocal to each other. And cotangents are positive, except that everything is negative. Okay. In the fourth quadrant, cosine and secant, because you know the cosine and secant,
they are also reciprocal. Tangent and cotangent, they are reciprocal. That's why. So sometimes people try to remember this line. They try to remember this line, that all students take calculus. That is a memory aid. So all means first quadrant, all functions are positive. Second quadrant, sine are positive. You see the students sine, the S. Third quadrant, tangents, automatically you know that cotangent will be positive. So it's take and calculus for the cosine in the last quadrant. So sometimes I try to remember all sine 10 cos. That's how I remember. But if you want, you can just remember this line, that all students take calculus, so you'll know which quadrant, which one is positive. Okay. Let's see whether we understand this. Let's read the question and we'll come back to that graph again. Name the quadrant in which theta lies if cotangent is positive and sine is negative. Now let's get back to this original graph of 4 quadrants with all the information of the sine and cosine and all the 6 functions. Now what was the question? That cotangent is positive, sine is negative. Which will be that quadrant? Now first of all, try to think which quadrants cotangents are positive. 3 and 1. In 1, everything is positive, right? So the cotangents are positive here and here. These are the 2 quadrants where cotangents are positive. But again, there is one more condition, which is sine is negative. Now think about that. In this quadrant, sine is not negative, right? Because sine is positive. Because here everything is positive, so the sine is also positive. So in quadrant 3, so they are referring to the quadrant 3. So the quadrant 3 is the quadrant where cotangent is positive, sine is negative. So that's the only one quadrant where this is possible. Okay. Any doubt? So anytime, based on the information, we'll be able to identify which quadrants they are talking about. Okay. And later on, I can probably show it right now, because I don't want to confuse you right now, because I don't want to give you too many information at the same time. So there are reasons why, I'm just telling you this line, and later on at some point I'll explain why. There are reasons why different functions are positive in different quadrants. And most of those reasons are basically coming from the positive and negative side of the y and x axis. Okay? Because for an example, let's say when you are talking about this quadrant, okay, look at this. This will be your, whatever the adjacent will be, your adjacent will be here, right? Your opposite will be from here. And look at it carefully. This is the negative side of x. And this is the negative side of y. You see what I'm saying?
since they are negative side of x's and y's, if you take the ratio of those, some of those ratio will be negative. Not all. Some of those ratios. Probably, for an example, why the tangent is positive here. You can probably make some sense like this. What is tangent? Opposite over hypotenuse. Not hypotenuse. Opposite over adjacent, right? Now here, opposite is negative, right? Adjacent is also negative. So when you have two negatives, that becomes positive. You see what I'm saying? That's the. I'm just giving you a little clue, not too much, because later on we'll probably see it in the bigger picture. At this point, I'm just giving you a little idea that why it happens that in that quadrant only the tangent is positive, and the cotangent is also positive for the same reason, because the cotangent is just adjacent over opposite, because they have two negatives, it's cancelling out. But in case of the sine and cosine, what happens? You are dividing the adjacent by hypotenuse. Now the hypotenuse is not ever negative because the hypotenuse is coming from here. Okay, so whatever the x and y, they are getting squared. So even if they are negative, after you square it, they becomes positive. Okay, so the hypotenuse is never negative, for an example. So when you divide, like for an example, adjacent over hypotenuse is negative, right? Because the adjacent is negative, hypotenuse is positive, overall ratio will be negative. So those are some clue, because I'm just trying to give you some idea that why in different quadrants, different functions are positive and negative. At this point, we'll just use the memory aid, and we'll just use that aid to identify these. Now, let's look at this question carefully. We are given the cot theta, which is, look, in this question, they didn't mention which quadrant it is we're talking about. Look at the value of the cotangent, that is negative, right? That is negative. Now, first of all,
and also look at the sign. They said the sign is positive. Now, which quadrant it is? It must be number 2. Look at this. Whenever you know that the cotangent is negative, let's go back to that slide. We know that this is not the quadrant for sure, because nothing is negative here. And this is also not the quadrant, because cotangent is positive here. So whenever they are saying that cotangent is negative, it is either quadrant 2 or quadrant 4. Because these two quadrants, cotangents are positive. I'm sorry, negative. But they also mentioned that sine is positive. Look at this, sine is positive here. But sine is not positive here. So it must be second quadrant. It must be second quadrant. Now, let's go back to that slide. Now, whenever it is second quadrant, now let's say what is known to you. You have to find the other four. So there are the four trigonometric functions from here. Now, what is given to you? You are given x and y. Which one is your x and which one is your y? How do you know? Look at the cot. What is cot theta? What is the ratio? Adjacent over opposite, right? So this is your adjacent and this is your opposite. Now, you are given negative 4 over 3. This is what you are given in the question. Okay? Now, can anyone here tell me, see, this negative sign either can come from these or these. We don't know exactly. Okay? So you have two options. You can assume it with anyone, and then later on you can figure out the sign based on the quadrant, because we know that the theta lies in quadrant 2, right? We figure it out that that's on 2. So let's assume that x and y's are just based on our understanding is basically this, because what happens is in second quadrant your x's are negative, right? Look at the second quadrant. This is the negative side of x, right? But the y's are still positive. We don't have any problem with the y's. So that's why I keep the x as negative, y as positive. Because one of these is negative for sure, right? We don't know which one, because it may be these or these, but just from the second quadrant we know this. Now,
how to find the sine from here. Let's write the sine. Okay, now before that, we probably want to make sure we know the r, because we'll need the r for several other ratios. So how do you find r? Is x square plus y square, which is minus 4 whole square plus 3 square, which is 5. See, when you are doing the square root, you get plus or minus, but this plus or minus, this negative doesn't make any sense, because you are just finding the radius or some kind of length in this case, because that is not along x or y. So r is 5 in this case. So now when you are looking for the sine theta, what is sine theta? Remember the ratio? Remember that line? What is the ratio for the sine? Opposite by hypotenuse, right? Opposite by hypotenuse. Now this is your theta, so this is your opposite by hypotenuse. You can also look at those formulas at the first slide. If you go back, let me go back here just to make sure that you know it from here as well. We wrote all of this. Look at this, y over r, which is the sine theta. If you want, you can just write it down, because we will need all this for the whole slide, so that we don't have to come back to this slide again. And also try to match with your concept that how it is calculated, because sine is opposite by hypotenuse, the cos is adjacent by hypotenuse, tan is opposite by, or maybe I can write it here just to make sure we remember again. Sine theta opposite by hypotenuse, adjacent by hypotenuse, and then tangent is by adjacent. I think we don't need the other three, right? Because those are reciprocal of cosec is reciprocal of
Sine, and then cos is, and then sec is reciprocal of cos theta, and then cot is reciprocal of tan theta.
Alright, so let's go back to that question. Okay, so the sine is y over r. So y is 3 and r is 5. So this is going to be the sine. And also, after you have, make sure your sine is right. What will be the sine? It's positive, right? Because it's in second quadrant. In the second quadrant, sine and cosec is positive. So you are right. So you got that right value. And how about the cos? Cos is x over r, right? What is x? Negative 4 over 5. And also, just to make sure, this is negative, and your second quadrant cos should be negative, right? Because the second quadrant, only the sine and cosec is positive, are positive, except that everything else are negative. So cosec must be negative, which is true here. How about, let's see, how about the other two? Sec theta and cosec theta. So you have two options. Either you can write their original ratio, or you can get it from the reciprocal of sine and cosec, because this is reciprocal of cosec. I'm sorry, cosine. Sec is reciprocal of cosine, and cosec is reciprocal of sine. So this is going to be negative 5 over 4. This is going to be 5 over 3. Or you can get it from their original equation. I'm sorry, original ratio, because the sec is hypotenuse over adjacent. So, any question here? We don't encourage you to memorize all of this, but at least you should remember how you get sine, cos, and those three. I think if you remember those three, you will be able to find everything else. So that's the only three you should remember, and then everything else can be derived from there, because the other ones are the reciprocal and other three functions, and in most cases, even here, we are defining the trigonometric functions in terms of x, y, and r, which is again from those original ratios. So as long as you know which is your adjacent and which is your opposite. Any question here? All right, so let's see how we can find the reference angles, because a lot of times in trigonometry we have to find an angle called reference angle, because when your angle is too large, okay, let's say it is greater than 360, or is something greater than acute angle. How do you find a reference angle? So finding a theta in general, the theta in the standard position, because at this point we are talking about the standard position. So standard positions means it can be either in its quadrant 1, quadrant 2, quadrant 3, quadrant 4, anywhere. Okay. So in general, it is not an acute angle. We know that the acute angle means it must be less than 90 degree, right? It will be 0 to 90. That means the acute angle. Now, the reference angle is a positive acute angle. Okay. Terminal side of theta. What is the terminal side? So this is the theta. This is called the terminal side. Okay. Formed
by the terminal side of the theta and by the x-axis. Now, how can you find that?
Now here, some examples are here. Let's see whether we can find it out. Remember, what we are going to do is, we are doing something like, we'll find an angle alpha less than 360 or 2 pi, because 360 or 2 pi is the same thing. That is coterminal with the given angle. Whatever the angle you are given, based on that we'll be finding that, and draw alpha in a standard position, and then use the drawing to find the reference angle for the given angle, the positive acute angle formed by the terminal side of alpha, and the x-axis is the reference angle. Let's do a problem, then we'll probably understand it much better. Now, let's say we have 4 pi over 3. How can you write it as? Let me show you how you want to write it. You will always convert any angle such that it becomes 2 pi minus something, or 2 pi plus something. Can you write any angle such that, like that? I think of course you can. For an example, let's say what is the first one? Is 4 pi over 3, right? Let me show you how you can do that. Now, to make in 2 pi here, since this is 3, look at the denominator, it's 3, right? So you will need double of that, because you are going to make 2 pi. So you will be making, I think, 6 pi minus 2 pi, because I made 6 minus 2 because I have to make 4 at the end, right? It has to be 4 over 3. Now, when you divide both number by 3, it becomes 6 pi by 3, and this becomes 2 pi by 3. What happens? This is 2 pi right now, and this becomes 2 pi over 3. Do you see we converted? As I said, every angle can be converted back to like this. You'll be either writing 2 pi minus something or writing 2 pi plus something. Okay. Can you try the other three and see? I'm sorry, other two, and see what you get. Remember, the last one is in degree. The degree symbol is missing, but this is negative 120. Okay. So there is a degree symbol. So what is the answer for the other two? So there is another way you can try if you like. You can draw the original angle in the graph, and then for an example here, what is this? It's 4 pi divided by 3. So how much is that? If you convert it back to degree, it becomes 240, right? From radian to degree, right? If you use the conversion factor like this, 4 pi by 3, conversion factor is 180 over 3, 80 over pi, right? So your pi and pi get cancelled, and this becomes 240. You cancel 3 times 60. 4 times 60 is 240. Now if you try to draw the 240 in your let's see, probably you get a better one, because you can get a better for an example here, you can draw it here. What will be 240? You go up to here, 180, right? You go another 60, which becomes 240 here. That's it's not probably 60. Let's see, it will be a little bit more. Yeah, it's maybe 60. Okay, so this is basically 240. So once you draw it, another option is, instead of going to that route, you can just take your x-axis and this angle can be also considered as a reference angle, okay, which is just 60 degree here. That's another option. So I think this is the method book used. It's probably better because you'll probably look at the book examples. So maybe you draw it there instead of just going to the algebra. Just draw it and see how, and theta or alpha or whatever the angle you have, that take that and x-axis, that will be your reference angle.
Okay, these and these. So that is going to be your reference angle.
Now, if we didn't use the algebra, you're saying add 2 pi or subtract 2 pi. But how do you know whether to add 2 pi or subtract 2 pi?
Oh, it's based on what you have there, because
So
if you
over 1,
over 2, because for an example, let's say here, if this is more than 6 pi, you'll be adding, because this is 3. If it is more than double, let's say if it is 6, if it is more than 12, okay. But if you ignore that, I think this is more easier. If you like, you can just pick this. So just draw it in the, just draw it there. Draw after you draw, and then between your terminal side of, this is the terminal line of your angle, and then x-axis, that's going to be your reference angle. That will be more easier, I think. That's easy to deal. So just take that as a reference angle. That will be easier. So one option is, maybe we'll be using that. I thought that might be more easier for you instead of just doing the algebra. So for each angle, we'll first draw it. For an example, the last angle, what do? Because the angle is negative. So you will go clockwise. 120, that might be starting from here, that's 90, and go again 30, that's 120 maybe. So here is probably 120, but remember, this is the terminal side of that angle, but you have to take the reference angle, which is between terminal side and x-axis, which is of course which is acute angle. So because you cannot take this part, because that's not acute angle. So you'll be taking this part, so which is here, which is what, 60 degree? This will be 60, right? Because this is 90 plus 30, so this is 30, so this must be 60, right? Because this is 30. This part is 30 here, and this is 90. So 90 plus 30 is 120. That's how we got 120. But your reference angle will be 60 for this. But remember, the reference angle at the end, it will be a positive acute angle. Okay, but at the same time, you know that there is a quadrant issue, right? Because based on the quadrant, we'll know whether that will be positive, negative later. Okay, because since this is 60 degree, we know that this is the quadrant for tangent and cotangent, so everything else will be negative here. Doesn't matter what angle it is. So best is you draw that. Now, if you don't feel comfortable with the radian, because I know that sometimes it's really not easy for the radian, so just convert the radian into degree using the conversion factor 180 over pi. Once you multiply it, you get the angle into degree. Draw the angle. Once you draw it, just take the terminal side and then take x such that you get a acute angle, and that is going to be a reference angle. Because some people might get confused that okay, this is x, this is also x. So which one I consider? Because if you consider this x and this reference, the angle will be not acute angle, right? This will be more than 90. So you take this and this, that will be your acute angle. Now, so again, as you see, in literature, if the original angle is theta, they call reference angle as theta prime. Okay, remember that's just some kind of notation we do. Or the original angle is alpha, reference angle is alpha prime. It's just the way we write, but at the end of the day, that's the same thing. Now, can you do it for 405? Now, what happens with the 405? Now, there are two options. If it is 405, you can simply subtract 360, because that doesn't make any difference, because you will just complete the whole cycle and then go further, go beyond, which will be like starting over. Okay, so you can simply subtract 360 and then you'll be left with only 45. So you can start 45 from but make sure you know the direction. At this point, this is positive, so you'll be always going anti-clockwise. So you can go just 45 anti-clockwise, which will be still in the first quadrant, and the reference will be also 45 degree. But it's up to you how you feel better. So if you think that you just want to consider the whole angle, doesn't matter how big it is or how small it is, it's up to you. Just if it is more than 360, you'll be just rounding one time and then come here, and that's going to be a 405. Because when you completed the round, you already completed 360 plus 45 is basically 405, and the reference angle is going to be x.
Angle between x and this terminal side, which will be 45. Yes, for the last one. Yeah. How about the first two?
Maybe you can draw and see. At some point, probably you will not have to draw. You'll just can answer right away. No, just do it in the graph. So we want the graph and so What is the reference angle for the first one? 7 pi over 3. How much? 60? Everyone has 60? Let's see, it's 180, 30, 210. Yeah, that's yeah, that's 60. How about the second one? 30 degree? Yeah. Remember, the reference angle will be always less than 90 degree and greater than 0 degree, and that will be a positive angle. Okay. So, at the end, by the reference angle, you are getting something which is an acute angle. Okay. We have a lot of application of the reference angle here. So, evaluating the trigonometric functions using the reference angle. Now we know how to get the reference angle, and we'll see how we can use this reference angle to calculate the trigonometric functions, to evaluate the trigonometric functions. Now, the value of the trigonometric functions of given angle are same as the values of the trigonometric functions of the reference angle, except possibility for sine. Be careful about that. Interesting is, when you are trying to find the reference angle, let's say your reference angle is 30 degree, okay? So the value of the trigonometric, so for an example, you are trying to find cos 270, for an example, but what you do is you first find the reference angle for 240, okay, which is what, 60 reference angle. So basically the cos 240 and cos 60 will have the same value except the sine issue. You see what I'm saying? That's exactly what we are trying to make sure, that that will have the same value. So that's what they said, that the value of the trigonometric functions of a given angle are same as the value of the trigonometric functions of the reference angle, except possibility of the sine. So we know the sine from the other chart. We know exactly how the sine will be changing, but remember, the sine will be determined by the original angle. Since that is 240, we know that that must be lying in quadrant 3, right? 240 is larger than 180, less than 270, so that's quadrant 3. So we'll be deciding the sine based on that quadrant, but the value, the absolute value, will be coming from cos 60, because 240, the reference is 60. So now, a function value of acute reference angle is always positive in general, because that's all falling in first quadrant, because you know you're taking the acute. However, the same function value for theta may be positive or negative based on the original quadrant where it was falling. Now, what is the formal procedure? Now, first we do the value of the triangle function reference angle, the way we did just right now, and the function for theta prime, if it is 60 cos 60, we know what it is. It is
tan 60, we know what it is. We'll find that. And we'll use the quadrant in which theta lies, original theta lies, to prefix the sign to the function in step 1. As I said, for an example, you are dealing with 240, so you get the reference angle, which is 60, and you are looking for, let's say, sine 240. So now you'll be looking for sine 60 instead of sine 240, because the reference angle is 60. Once you know that, you will just find the sine from the original angle, because the sine 240 is falling, the 240 is falling into quadrant 3. In quadrant 3, sine is negative, so the value will preceded by a negative sign. Let's try some examples. Okay, before that, so we'll come back later. That might be, so these are some, remember, we probably tried it yesterday. Remember I said that how I do it, starting from 1, 2, 3, even I continued up to 4. I divide everything by 4, and then I square root those. How to remember the sine and cosine from 0 to 90. 0, 30, 45, 60, and 90. They're just showing you the same table, that how you remember it. But they have different approach, you know, it's up to you. But in general, what they do is they just consider some right triangle like this, and based on that they try to find it out. But I think
Our steps were not hard because what we did was we just started from 1, 0, 1, 2, 3, 4. We divided everything by 4 and we took the square root. So the first value was 0, second value was half, the third value was 1 over square root 2, fourth value was square root over 2, last value was 1. And all of those are values of sine. The first one is called sine 0, second one is sine 30. Okay. Now again, so if you don't remember, we have the calculator, you will know it, but these are the basic values we will be using a lot of frequently. So here, how can you use the reference angles to find the exact value of each of the following trigonometric functions? Now here, let's say the first one is sine 4 pi by 3. So the 4 pi by 3 is 240 degree, right? 240? It's 240 degree. Now first what we do is, for 240 degree we'll find the reference angle, which will be 60. Is the reference angle 60? Check, just draw the graph and see whether the 240 is 60. If you know that 240 is 60, then just find the value of the sine for 60. Let me see whether I can, let me remind you that those values again. Let's see whether. All right, let's see. So what we did again, they have another approach, but I think our ones are easier. So I just write 0 to 4, and then I divide everything by 4 first. And then this is still 1, this is 0, and I just took the square root of all of this. If I do the square root, this becomes half, and since this is already half before the square root, and after the square root this becomes 1 over square root of 2, this becomes square root 3 over 2, and 1 is 1 because after the square root is still 1. And now this is your 0 degree, 30 degree, 45, 60, 90, and all of these are for sine. Okay. But for cosine or cos, the degrees are reversed. So this is 0, this is 30, this is 45, this is 60, and this is 90. And you know, when you know sine and cos, you'll be able to know everything else, because everything can be defined from sine and cos, because the tangent is nothing but sine over cos, and the other three functions are just reciprocal of all these three. So all you need is just, and these 5 degrees are extremely crucial, because you will see these degrees extremely frequently. So that's why most of those calculations you can get it from there, 60 or 30 or whatever. So what is sine 240 then? Here, scientific mode is 240. That
is basically square root. Yeah, there's negative square root over 3 over 2, which is this. Because, you know, sine 240. So what do you do? Step 1. What do you do for sine 240? First, we know this angle is 240. So we first find the reference angle. How do you do it? It's a positive angle. So we start from here. 240 should be here, right? So you draw the angle here. Okay, that's 240. Now what is your reference angle? Reference angle is going to be this. That's terminal side and the x-axis. So this is going to be 60, right? So what you want to do is you want to find the value of sine 60, which is
square root 3 over 2. But at the same time, once you have the value, you'll see what will be the sign of that. Remember, this is the all sine, tan, cos, right? So this is the quadrant for tangent and cot, tan and cot. So in this quadrant, sine is negative. So this is going to be negative basically. So which is technically that is the value. So this should be your answer. Try the other two. See whether we can find those. Oops. All right, so any answer? How about the last one? 10 minus 120. So anytime you see the negative, you should start from you always start from this reference axis. But since it is negative, you start going to the clockwise direction because it's negative. So how much you get? Negative? Tangent, the last one. Positive these? Square root of it? Okay. Now let's see whether we get the same value. Okay, here, so we start from here and then go clockwise because the angle is negative. So it's 120 is here maybe. So this is 30 degree. So that's, this is 30 degree, but your reference is 60, right? You always create the reference with the x-axis, not with the y. So you are going from here to here. Once you draw it, you know that reference will be between x and that terminal line. So it will be 60 degree. Now tan 60. What will be the tan 60? This is the sine 60 and this is the cos 60.
Right. So, what is tangent? What is tan 60? Tan 60 is sine over cos, right?
So which is how much? What is sine over cos? So it's a square root 3, right? This is your tan 60. What do we did? Okay, let's do it again. Okay, sine 60 over cos 60. Sine 60 is square root over 2, square root 3 over 2. Cos 60 is half. Do the math, you will get square root 3. Now this is your tan 60. Now you have the absolute value. Let's look at the sign. What do you think? What will be the sign? Sign will be positive because this is in quadrant 3 and you are talking about tangent. This is the quadrant for tangent, right? All sine, tan, cos. So this is the quadrant for tangent. So it will be still square root 3. If you do it in the calculator, you will get like 1.73, you know, it will never stop. That's the square root of 3. Any question? Oh, in the answer? First of all, if it is in multiple choice, you don't have that option. You always will choose the right answer. But in general, I would prefer this. If you have an option, because you know, in MyMATLAB, when you are answering, you will see that you can write the square, you can choose the square root and all of those from the left side. Do you see that? That you can choose the square root and those symbols from there. I would always prefer this because this is absolutely accurate because you cannot basically write it in decimal number to make it accurate because you know we don't have, even if you write 1.73, it's not accurate because it doesn't end. So if you have option, because you know in MyMATLAB I know that you can write a square root 2, so it's better write a square root 3.
It tells you to change
Yeah. But I'm saying, if it is square root of 3, just write square root of 3. That's the best, because you are exactly, accurately writing this. Remember one day I said that instead of writing pi equals to 3.14, I always feel more comfortable when I write 22/7, because I know that's exactly how the pi is coming from. But you cannot write it in this. But I know that a lot of places you cannot do that. So, but in MyMATLAB we can do that. So just write whatever it is, because that's the reason we always want to write it in this form, because I know that this is one of those which you cannot write in fraction. Half is fine. You can write half because it's 0.5 and that's accurate exactly. So it doesn't matter if you write 0.5 or 0.5 or 1 over square root 2. Doesn't make any difference.
So like on the second one, we convert that.
Okay, second one.
6 degrees.
See, you don't have to. If you understand in the radian, that's fine. But if you don't feel comfortable, do that. Yeah.
Draw the graph.
Which is how much? Is 210 degree? Okay, 210. Yeah.
Okay. Once you get that,
Let's draw it. Let's do it here. Then we'll be more comfortable. So let's draw 210. That's positive 210. So we'll be going anti-clockwise here. Maybe, right? So the reference angle is going to be 30 degree, right? Because this 180 plus 30. Now, we are looking for cosine 30 degree, which is what? This is for cosine 30 is square root over 3 over 2. This is the absolute value. Now, how about the sine? It's negative, right? It's in the third quadrant. All sine, tan, cos. So this is the quadrant of tangent. And say it again. Okay, so this is negative. So the answer must. So make sure you SF we have, because it's falling in quadrant.
And 3. The original, remember, when we are calculating the sine, we look at the original angle. We don't look at the reference angle. The original angle was here, right? It was falling in quadrant 3. In quadrant 3, tangent is positive. Cotangent is positive, nothing else. Since this is cosine, it's negative. Everything else is negative except tangent, and because you remember, all sine, tan, cos. Or maybe all students take calculus, however, whatever you feel better. Any question? Okay, let's move forward. So these are again, let's see. Let's try all of these, because these are almost the last slide of this. Because the next question we don't have to practice, because anytime you are doing this, you are automatically calculating the reference angles. So there are plenty of examples. So make sure you do it. Just try it and get the answer right away. Because once you draw it, it will be extremely simple, because you'll be having something from here, right? All the values are here.